Hello, good morning, guys. Okay, so this is a very last minute video, okay, regarding to the Amali KIMIA chemistry tomorrow. Okay, so this is I prepared a few sample questions, okay, because I heard there are a few sets of, like two sets of questions. Okay, so this is the first set, the most popular one, okay, everybody talking about it. So here, you can see, I found a sample question. So this is an experiment to determine how temperature of sodium thiosulfate can affect the rate of reaction. So when you are doing your Amali, right? So please remember, Amali, right? The experiment, they can always change the things in the experiment. And this is why the result that you all do in school might be different from what you will be doing tomorrow. Okay, so please be very careful with the procedure. You should read the question and the procedure carefully and never memorize data. Okay, don't use the old data and put it into the your Amali paper tomorrow. Okay, read the question. Normally, the questions, right, will tell you what they're doing. So here they told you that temperature of sodium thiosulfate affect the rate of reaction. So it's usually MV of the experiment affecting the RV of the experiment. Okay, last week in the class, I already told you, when you are doing this experiment, right, before you do it, you must test your stopwatch first. Okay, must test your stopwatch first. Okay, make sure your stopwatch is okay and you also know how to use your stopwatch. Then only you start with the procedures here. So according to the procedure that I found from the textbook, experiment 7.3, the experiment here, it says you have to record the temperature of your first set experiment, which they're actually using room temperature. Okay, they are using room temperature for the first set of experiment. And you should know that this can always change in the question. They can ask you to start from maybe not room temperature. They can ask you to start from 35 degrees Celsius if they want. 30 degrees Celsius also can. So which you may need heat the acid, actually heat the sodium thiosulfate solution to this temperature first for your first set of experiment. So read the question carefully. Don't memorize blindly and put in the data. All right. So this one, it starts from room temperature based on the procedure. Okay. But the question I give you at the back is actually start from 35 degrees Celsius. So please don't memorize my data. I simply put in the data myself, actually. I never carry out any experiment. I just simply write some data. So here, I want to go through a few questions with you all, which most of you keep on asking me, like how to do operational definition, how to write inference. Yeah, I will go through all types of questions here. First, recording data and constructing table. If they just want you to record data, they will give you a table for you to fill in all the data. Okay, they can also ask you to construct the table yourself. You have to draw the table yourself and put in the data. So here, this is what you have to be careful. When you are recording, you are writing the temperature, okay, into your table, right? Remember to put unit, okay, and then one decimal place for temperature, and then the time taken for X mark to disappear from view. This one, if you are using a digital stopwatch, the one with screen, digital, the LCD one, I think, okay, you have to give 2 decimal places. If you are using the old school analog, okay, stopwatch, old school one, analog stopwatch, you have to give 1 decimal place. So let's say I'm using digital stopwatch. So my result will be 11.11, 8.56, 6.44. If you are using the analog one, your reading most likely will be like 11.0, 8.5, maybe 6.5, maybe. Okay, I don't know. So 1 decimal place, 1 decimal place. Okay. And then, right, they might ask you to calculate 1 over time. What is 1 over time? 1 over time here is actually rate of reaction. In class, right, we keep on saying rate of reaction is using quantity to divide time. But in this experiment, we can't find exact quantity, like how much precipitate has produced to cover the X mark. So we can only use 1, okay, as a standard for all the experiment. We use 1 and then we divide time. So this is the value that I got when I use 1 to divide 11.11. And then I give them 3 decimal place. Okay, can. So if and only if this is given in the table and they want you to calculate, then you calculate. If they only give you this part, then you just fill up this part. If they want you to construct, right, you can always read what they want. Like they say, construct a table to record the data. The only data you got from the experiment is this one. Then you just record this one. Some students, they like to ask me like, oh, do I draw the horizontal table or vertical table? Up to you. Up to you. Okay, as long as you present your data nicely. Okay, so this is my sample of data. 1 decimal, 2 decimal, and 3 decimal places. All right, okay, next. Second type of question. They might want you to plot a graph, and here are different graph patterns. If the question want me to plot a graph of temperature against time, so remember, doing Amali, don't panic. Just read the question carefully, and then you just follow whatever they want. They want you to plot a graph of temperature against time. Then I just plot my data. Assume that this is the data I got. I just plot the data. I just plot the data on the graph paper, and then I join the points together. For temperature against time, you're supposed to get a curve. Okay? If the question change, so please don't memorize blindly. If the question change to 1 over time, this is my graph of temperature against 1 over time. Remember, it's always x, this rate. It's always y-axis against x-axis. Y against x. So I plot my points, and then I connect them together in a straight line. This one is straight line for 1 over time. Okay, and then it's actually okay if one of your point is like that, let's say. Because we always draw line of best fit for rate of reaction, line of best fit. So if one of your point is like away from the curve or the straight line a bit, is actually okay. Okay, okay, next. Prediction based on graph. If they want you to draw graphs, most likely they will ask you to predict some results from the graph. So for example, this question, they want me to predict the time taken or determine the time taken for the X mark no longer appear if the temperature of the sodium thiosulfate is 45 degrees Celsius. You see, just now my experiment, they never asked me to carry out 45 degrees Celsius. But this one, they want me to find the result of 45 degrees Celsius, which is here, okay? Let's say I have a graph paper. We should use the dotted line. Go to our straight line. Okay, then we go down. Here, I think it's around 0.14 But remember, this is your rate of reaction as -1. So I'm going to use this rate of reaction, which is equals to 0.14, to calculate my time taken. Rate of reaction is equal to 1 over T. I sub it in. 0.14 equals to 1 over T. My T will be equals to, let me press my calculator. I think it will be 7.143 as -1. As -1 pula. S time, because it's time. Oh, time 2 decimal place. If it is time, then 2 decimal place. 7.14 second. Okay, can. Next. Predict the rate of reaction at 60 degrees Celsius on the graph. Explain your answer. Okay, they want me to use graph again. You see, 60 degrees Celsius. 60 degrees Celsius, right? You see, it's here. I need to extend my graph actually. You have to extend your graph further a bit so that you can get the data for 60 degrees Celsius. So maybe it is around like 0.19. Did I just write 0.19 as my rate of reaction. Then they want me to explain, like, hey, why is it 0.19? So you can see that 0.19 is actually the highest out of all these sets of experiment. 0.19. So what I'm going to tell them is, oh, because the temperature is higher, so I get a higher rate of reaction. Okay, so the higher the temperature of sodium thiosulfate solution, the higher the rate of reaction. That's all. Hypothesis, guys. Hypothesis for rate of reaction is always the relationship between your MV and RV. So that means you might want to do your MV and RV first. Remember, for hypothesis variables, observation and inference are something that you can read from the table. From the table, from the textbook or from the question itself. So without doing the experiment, you can also actually get marks from this kind of questions. So let me do my MV and RV first. MV, manipulated variable, is the things that change in the experiment. And you can easily find this MV at your last procedure. Okay, usually it's last procedure, which is the one that's saying repeat. Okay, now I go back to my procedure. It says repeat. Okay, repeat. Step 1 to 8 by using sodium thiosulfate at different temperature. Okay, this one is based on textbook. That's why there are a lot of sets of experiment here. But for yours, most likely they will ask you only carry out 3 sets. Most likely it's only like maybe 40 degrees Celsius and 50, that's all. Okay, but you can still see your MV here. They are using different temperature of sodium thiosulfate, or based on the question we already know. So I'm going to write my manipulated variable as temperature of sodium thiosulfate solution. Responding variable. Responding variable is what are you trying to find out in this experiment? You carry out this experiment for what? What are you trying to find out? Okay. Usually what you want to find out, it can be the data that you want to collect, or what are you trying to find out? So here, according to the data that I want to collect, it is time taken for X mark to disappear from view or sight. Okay. Or you can actually just write rate of reaction, because I'm doing this experiment to find out the rate of reaction. This also can acceptable. In case you are getting a different set of questions tomorrow, you don't know what to write. You don't know like what it is a time taken or what. Don't worry, just write rate of reaction. Okay. Then for constant variable, you cannot simply write anything that's same. Some student told me that, oh, I use the same stopwatch for all sets of experiment. Can I write stopwatch? No. Constant variable, the answer has to be something that can affect your data. That's why you want to keep them constant. The answer here must be volume and concentration. Must write both volume and concentration of sulfuric acid, which is another solution. For all 3 sets of experiment, the sulfuric acid use the same thing. But sodium thiosulfate, you change their temperature. All right, understand? So now I got my MV and RV ready. Then I can do my hypothesis. The higher the temperature of sodium thiosulfate solution, the shorter time taken for X mark to disappear. Or I can also say, the higher the temperature of sodium thiosulfate solution, the higher the rate of reaction. Next, observation and inference. Observation is what you observe, what you see. Like usually it's something produced in the experiment and we describe their color. In this experiment, it is going to produce yellow precipitate. Even though if you got something like milky white tomorrow, you still have to write yellow precipitate, because according to theory, the substance is actually sulfur. Sulfur is yellow. So observation is like give people a hint like, oh, you see yellow precipitate. Then what is inference? Inference is like, now, you tell them, what is the thing you see just now? I see yellow substance just now. What is the yellow substance actually? Sulfur. So yellow precipitate found. I just tell you the color, the appearance, without telling you what is that. But now in the inference, I tell you, the yellow thing is actually sulfur. That's how I give inference. Okay, it's like give an explanation to what you see. Lastly, operational definition. There are a few types, okay? Depends on your teacher's pattern. Normally, teacher will teach you to do this pattern, what you do, and then what you observe. What you do and what you observe. So based on this pattern, I should get when sulfuric acid is added into sodium thiosulfate solution, yellow precipitate is formed. So you can see the way I writing what you do is I'm telling them which chemical I mix with which chemical, which thing we mix with which one. Then the observation, yellow precipitate is formed. This is the shortest and easiest answer already. If your teacher don't like this one, they might want the second type of question. Second type of answer, which is operational definition is the time taken for X mark to disappear from view when sulfuric acid is added into sodium thiosulfate solution. So this type of answer is like you're telling people what to observe. It's like what is the data you want to collect in this experiment, like what you do, and then what's the data you want to collect. There's like a different way of writing the answer. So you might want to ask your teacher which one they prefer. Okay, the third one is very similar to the second one. You can read it yourself. Okay, then this is like dan lain. Dan lain is theory questions. Okay, if they never ask you to plot a graph, they might ask you some theory questions. You can read through this one. You can get the PDF from the link below the YouTube video. Okay, I post the link below the YouTube. Okay, that's all. Bye bye. See you guys.